Introductions. Please let me introduce Greg Kroah-Hartman. Greg is a Linux fellow at the Linux Foundation and one of the maintainers for the Linux kernel, certainly one of the highest velocity open source projects in the world, and he's graciously decided to come by and tell us all about operating an open source project like that at scale. So thank you very much, Greg.
Thanks. Close it. So we don't yell. Hi, I'm Greg. Please heckle. It's harder with Hangouts, but please heckle or ask questions. This makes it more fun. It is the largest. Linux kernel is the largest software project that we know of ever by size, number of people contributing, and number of companies involved, and the speed. So I'll talk a little bit more about that. I'm a kernel developer. I maintain the stable kernels. Stable kernels, Linus does the development kernels. I do the stable kernels. I'll talk a little bit more about that later. I also maintain large chunks of the kernel, driver, core, TTY, serial, USB, staging, a lot of other stuff that I keep forgetting about. Miscellaneous character drivers, not networking drivers. So Linux kernel. So let's talk about this. This is the size of the kernel as of the last release, which was a couple weeks ago. 21 million lines of code, 53,000 files. 21 million lines is interesting. You don't run all 21 million. You run on my laptop runs 1.3 or 1.4 million lines. Your phone runs 2.5 million. That's the interesting thing. Phones are another problem. But so you all run the core of the kernel. The core of the kernel is 5%. Everybody runs that. Drivers are about 45%, but you only run a few drivers. Networking is about 20%, depends on what part of networking you're using, and it goes on there. But the core of the kernel is 5. Everybody uses that, and it's all spread out from there. Architecture specific's about 35–40% as well. Those numbers don't add up, but they're kind of close. So 4.6 kernel. This is our size what we did last year. So we finally cracked over 4,000 individual developers last year for the last release, so June to May of this year. At least 450 companies. I say at least because I haven't kept track of the numbers. We're doing a paper again soon, and I need to start asking people who they work for. So that's our best guess. If you contribute to the kernel and I don't know what company you work for, what domain you are, we ask. So it's that simple. So I'm guessing we'll probably be around 475, maybe 500 companies. I haven't done the numbers yet. But I know over 4,000 developers. So this is the largest we've ever been in the past year. Normally we've been averaging about 3,000 developers. This past year we went up again. So every year we keep getting bigger, kept getting more companies involved, and such like that. The last kernel we released had the most individual developers ever. I think I have to look up that number again, but it was the most individual developers that we had before. So this is our rate of change for the past year. It's not that bad. 11,000 lines added. Again, you guys can read the numbers. And it's not that bad if you think about this until you look at the units. So this is recorded, but the Linux Foundation has asked me not to use the word scary in presentations. I will use the word scary a lot. This is scary if you think about it. This comes down to we averaged 8 changes an hour last year. That's a lot. That's a lot of changes. The changes aren't only in drivers, so the changes are really unique to a project. The changes cut across the whole thing. So 5% of these changes are in the core of the kernel. We're changing the core. 50% or 45% is in the drivers. It's flat across the whole kernel, and it's been that way for over a decade. Every year I say there's no way we can go faster. There's no way we can keep up with this rate of change, and every year I'm wrong. Every year we go faster. Every year we keep getting incrementing and going quicker, and we keep making things go faster. A decade ago we were going 2.5 changes an hour. Microsoft and Apple told me we give up. There's no way we're going to keep up. We always have fun. And we keep going since then. So the only thing that's going to stop Linux right now is if we mess up. So my job is to make sure we don't mess up. That's really, really fast. The last kernel, we went even faster. We keep going faster. It isn't the fastest kernel we've ever done, but it is really, really close. We did a 9.3 about a year ago as well, but almost 9 changes an hour is a lot. These are the changes that are accepted. I looked at my numbers, so I accept about an average of 1/3 of the patches sent to me. So that's the average about what I get. Other maintainers get have a little higher rate of acceptance because they're dealing with more experienced developers. But 1/3 to 1/2 of all changes that are sent are only what gets accepted. So more is being created than is being accepted. So how do we do this? Two big things: time-based releases and incremental changes. A decade ago, we said, let's do a release every 2 to 3 months, because we were tired of this stable, unstable nonsense that took us years and years to go on. Let's do every kernel is going to be stable, and we're going to do a release every 2 to 3 months. And we've done it like clockwork. Oh, that number's wrong in the bottom. Every 2.5 months, we've done a release. So I think it's 67 days that Linus is averaging. He wants to go faster. I don't think we can go faster, but we'll see if we can do it. But it's good. So the best part about this is you don't feel pressure as a maintainer to accept something that's not correct. Because if you send me something and I say, no, go do some work, and you don't, and I want to accept your changes because I want to be nice and take your new work that you did, 2.5 months isn't a long time to wait. 2 years is for release cycle, or even 6 months is too long to wait, because then you have to get in the next one. 2.5 months is a nice time. You can go and you can figure it out and you can get it into the next release. And that's good. So it's a nice way for maintainers to relieve the pressure on them. It's a nice way for developers to know that their stuff will get accepted quicker, and they can get partial stuff accepted. It's faster as well, and that's good. It's also good for companies to plan. They know when we're going to do a release. There's a link off the kernel.org website. It's called the pointy-haired release guess. I don't remember what it's, something like that. And you can see for the next year when they think we're going to do a release and what the number is going to be based on what we've been doing for the past year. It's really easy to plot it. So you can say, I'm going to make a product that's going to ship in this time frame. What kernel should I pick as far as number-wise? What kernel should I pick as far as getting my patches into it to be able to be accepted? It's very, very simple. So it's a very, very nice thing. It's a good thing for maintainers, and it's something really good the projects should pick up, and a lot of projects have started picking this up. They do that better. I think the KDE and GNOME guys do it as far as a time-based. What does Kerberos do? Or Kubernetes do? What do they do? Time-based release? Pardon me?
It's sort of in between.
Okay. I suggest picking a time and then just sticking to it, because it's a good thing, but a short time.
How do you have flexibility in that time? Meaning, do you pick a date, say, look, this is 75 days, that's our goal, except, you get to 61 days and say, oh, we wanted to get this thing in and it's 80% there.
I'll show you how we do that. Okay. Yes, I'll show you how we do this release, how we get patches in and stuff like that. So, yeah. The other important thing is we want incremental changes only. So we make you break your work up into individual steps. Every patch can only do one thing. If you ever in a commit log say also or and I did, that means you need to break it up. And you need to break it up into small pieces. And small pieces, and we have a ton of engineers. We don't have a ton of reviewers. We need to make maintainers and reviewers' jobs easy. And if you break things up into tiny individual steps along the way, what it usually means is I can send something of a series of 20 patches, and me as a maintainer go, oh, great, you did great on these first 5, but look, you messed up on number 8. So I can take the first 5, and take this one, and then you reiterate and go and again. And with a pull model from Git, that's hard to do. Garrett is a really hard tool to do that. If you just use email and Git itself, you can pick and choose what you want to do, and I really recommend that for doing high rates of change. But it's good. So then you take the first 5, the developer goes off, redoes the rest of them, keeps on going. But break your work up into tiny pieces. Yeah.
So with incremental, is it a problem to make sure people don't put in something that's half done, and then users try to use it, and they get a bad experience because it's half done, or copy out user, or?
Well, we don't implement a feature that isn't done. Yeah. So, but we'll work on it. We'll get there partially, right, on the way. We won't implement, here's a new syscall, and just implement half of it, right? With the kernel to user space, the way we implement features is very different from a user-facing feature. It's either a new syscall or it's a new support new hardware, something like that. To support a new driver, yeah, we'll drop a whole new driver. That's self-contained. If you have that hardware, you care. Otherwise, it's not going to touch anybody else. But otherwise, like making new changes, we did a radical rehaul of the VFS layer recently. Alvaro took out a lock, and to get there, it took him about 80 patches to get there. But every single step along the way, the tree never broke, and it always worked. and that's a requirement as well. You cannot break something and then fix it later. Every single commit of our tree works for you. So our guarantee to people is that any kernel you use will work for you. We will not break APIs that you're using. Not that we will break APIs you're not using. And we will, it'll always be stable for you. And we made that guarantee for a decade. Companies finally started paying attention. Facebook did a test, and they went through 3 years of kernels on their infrastructure, like a little test cluster. Nothing broke. All our kernels. And you can go back and look at our past. We don't break things. So you should never be afraid to upgrade your kernel. So you have to upgrade. We want to give you the latest stuff, and we want to guarantee you that it's not going to break. So we won't implement a half-baked feature. We do implement stuff sometimes, and then just don't. In the very end, we will disable the syscall, so you can't get it. That's usually pretty rare. But again, the kernel is a little bit unique in that most of our code is hidden from users in the way things work. But we reiterate, and rebuild things internally. And it actually works out better. So when we were working on the driver model for the kernel, me and Pat Moschel decided, hey, let's do it this way. And as we started committing patches and making changes, other people said, no, you can break it down into smaller pieces and go everywhere else. So it's people reviewing it causes an evolution that makes it better for everybody else. So the fact that you have to do more work makes things better. And there's been a paper written about that as well, a few master's thesis on how we do that. So iteration, time-based release. Very good things. More work for developers, but easier for maintainers. And iteration, break things into tiny patches should be like, I would be stupid as a maintainer not to accept this because it's tiny and complete on its own, and it's obviously correct. So that's the thing to do. Yeah?
So, when this is around for a while, when a project's basic, you have to make it easy for developers to get developers.
Yes.
Was there a point where you sort of made the transition from easy for developers to easy for users? And can you talk at all, or you remember that time to talk about, we don't know Kubernetes where we should draw that line yet, I guess.
So,
we're not as awesome as we yet.
Yeah, it takes a while. We have always had a lot of developers. I think the big switch was when we went from Linus having an internal tree on his laptop to being BitKeeper in his public. So then all of a sudden, instead of me emailing him a bunch of patches and waiting a week to see, hey, did they make it or not, I could see if they were there the next day, if he got accepted or not, or if he took them all or not. And then we iterated from there. And that our rate of change took off. But that made it easier for developers to get feedback on what they had submitted that way. And then other people could see what I, as a maintainer of USB, had taken in my tree or not, because they didn't have to rely on, yeah, I think it's on my laptop or not. But that was 15 years ago. We made that break. You guys are having a lot of infrastructure problems. GitHub does not scale for large projects. It's really hard, as you guys have found out. I'm amazed you made it as far as you have. The Docker developers had the same problem, and they started splitting things up. And I'll show you how we split things up and making it things, our huge rate of change, but we have a very autonomous tree. We have people own different parts of it. I'll talk about that. So that's another way to break up your project to make it easier. So let's go on. So let's talk about answer a little bit of how we do stuff. So I'll say, so Linus releases 4.2.0. Numbers are just numbers. 4 kernel, 3 kernel, 2 kernel does not mean anything. Everything is stable. So we just increment the number. We went from 2.6 something big to 3.0 because I got tired of the numbers and said, if you see the number between 27 and 37, mentally you don't realize it's the same as between 1 and 10. It's just people math and things like that, their brains. So 4.2, when we get tired of the 4 numbers, we'll go to 5.0 and go on from there. So Linus says 4.2, and then we have 2 weeks in which all the maintainers throw all the stuff they have in their development trees to Linus. That's all the new features. And then he does a release candidate 1 for 4.3.0, and then from that point on, it's bug fixes only, or regressions. So we start testing the heck out of it, and we do regressions, and then he does a release every week. RC2, RC3, RC4, 5, 6, 7. And it's usually around 7 or 8 when things look like they're stable, and then he'll do a new one. So we only add new features that first 2 weeks. That's it. So that's our cutoff.
Do you know what the shortest number of RCs there's been to get to stable, or to get to release, and what the longest number of RCs?
I think we did a 6 once. I think we might have done a 6. That might have been coincided with everything looks fine, I'm bored, let's do a release. And I know we've been averaging number 7 and 8 for the past year. I think we did a 10 once when things were not working well and we had to revert stuff. But so, I mean, that gives us almost 2 months of just bug fixing and making things stable and making it. So that's how it works. So then we do 4.3.0 and go on from there. And so we started doing this about 13 years ago, and that was like, oh, this is great. But then we realized if there's bug fixes that we missed in 4.2, how do users get it? That's hard. So we came up with the idea of stable kernels. So this is what I maintain. So stable kernel, I fork it off of Linus's tree, and then do 4.2.1, .2, .3, .4, .5. I do about 1 release a week. And the rule is the patch has to be in Linus's tree in order for me to accept it. We never want to diverge. We never want to release 4.3 without the fixes that have already been in the stable kernels. And sometimes people will say, oh, but here's a fix that we need to rewrite it differently. It's like 80% of the time they rewrite it differently because they think it's done something else, they get it wrong. I'd much rather take a few more patches, like it's like, oh, clean up, and then the fix that they got in Linus's tree, I'll pick that in the stable because I want it to match identically. It's gone through the review. It's gone through all our test infrastructure. We want it in there. So then we do releases, and then that's it. I'm averaging about 100, 120 patches a week, stable. That's a lot for a stable kernel. Again, traditional computer science, you don't change what isn't broken, but the world changes, so we need to do that. So overall, I mean, when we're doing 11,000 patches in a release, 100 patches a week is pretty small. In there's a really defined thing. It has to be like 100 lines long, big, obviously a bug fix, or a new device ID, like new device IDs, or some quirk. But it has to be obviously correct, and it fixes the problem. And we go from there. So that's how we do. So distros run the stable kernels, developers run the development kernels, and all is good. We came up with this idea a long time ago. I used to work for SUSE and Novell, and I realized that stable kernel would make my job easier, so I started maintaining them for a long-term period of time. And companies like SUSE and Red Hat make a long-term enterprise kernel, so I use my day job to do that. And I realized long-term kernels are good because people make products on them. Android makes products, Chrome makes products, everybody ships products on these things. So let's make a long-term kernel. So we now have a long-term kernel idea. I pick one a year, and I maintain it for 2 years. So I'll take all the patches and backport them all, and after 2 years. And the funny thing is, after 2 years, the amount of patches that apply to it kind of fall off the edge. It isn't harder, but actually the work involved in maintaining a kernel after 2 years is more than it was the first 2 years, because things have changed and getting them in there right. Ben from the Debian kernel team maintains the 3.2 kernel, and he's still going to keep doing it, and he's averaging 6 to 8 patches a week. Is going into a 3.2 kernel that was released, 5 years ago. These are security fixes. These are bug fixes that people need. You have to have an updated kernel. 3.10 kernel, I finally stopped maintaining it. It's still, I mean, my phone uses 3.10. It's a maintained kernel. Android, there's a lot of Android stuff on it. 4.1, I think there's a lot of Chromebooks based on 4.1. 4.4 will be soon for new Chromebooks. It works out well. But you have to have your infrastructure to be able to update your kernel, otherwise it's broken. That's not really applicable to you guys. You guys can upgrade your stuff, but you can't. It's good to have something that people can maintain over time. The Debian model of maintaining one version for long periods of time is still, people think that's the right model for some reason. So you gotta live with the enterprise people.
So
yeah.
You said Facebook updated like 2 years worth of kernels and nothing broke. So your APIs are stable. So I think I know the answer, but I want to hear you say what's the motivation for long-term kernels if the APIs are stable?
The motivation is people's mentality don't understand. And the motivation is, the motivation is that. So if you look at, like, I'll pick on the Chromebook guys. They have a Chromebook with a 4.1 kernel, but they had to, because of when their release cycle, they had to backport a ton of graphics changes from an upstream kernel that would not be a stable patch to get it in there. And those conflicted in other different ways. Now they could upgrade the whole kernel every time, but they've done a lot of validation and testing and verification that they don't want to have to go through again. So they can look at these 10 patches a week, say, hey, look, that's great. Those are obviously correct. Let's ship those and go. It's a much easier development and release cycle for them.
It gives the security guys a chance to come for a long time.
Yes. It gives them something good to feel good about. And they don't care about new features. I might argue that they should care about new features, like we made locking in the kernel. I think between 4.1 and 4.2, Linus rewrote the core locks in the kernel, something you never traditionally do in an operating system, so they go faster. So maybe it would be good to update your machine, because then it would actually go faster. But they're happy with what they have. So it fits into a business model that a lot of companies have. I'd argue that they should upgrade all the time, but sometimes it's harder for them. So it's trying to pick the middle ground for them. Make sense? I don't know if I can get questions on Hangouts. Is there any questions on how we do this stuff? I guess we can't get questions on Hangouts. And no one has them. I doubt that. All right, let's talk about how we do this. So we have developers. Like I said, 4,000 developers last year. They make a patch, an individual change. Then they email it. Everything goes through email. They email it. They send off the series. Email's faster in the end than using Git to push through Garrett, because you can it works nicer. You can see things in a better way. Email is very flexible on the reviewer's side. They can sort it. They can verify it. They can pass it off to other tools really easy. You can have automatic tools that respond to it. We have bots that look at the patches on email lists and automatically test them. And goes off and says, oh, look, this one broke the build. Don't even, so then the maintainers know not to even look at it. It works out really well. It's a very low barrier of entry. All you have to do is send off an email, and you're good. Our mailing lists are open to anybody. Only rule is no HTML. Works pretty well. Maintainers get them. So every file in the kernel has a maintainer, hopefully, or a driver. So an area, we have about 700 maintainers that are listed. So they look at the patch, they say, yes, this was good, no, this wasn't good, need to redo it or whatnot, and then they'll batch them up, and then they'll send them off to the subsystem maintainers. And when they do that, they put their name on it. They say signed off by. It's a developer certification of origin. Linux has been doing that for a long time, but it's also a way for people to figure out where patches were reviewed by. So every patch that goes into the kernel, every line of code of those 21 million lines of code can be traced back to at least 2 people reviewing it. One person that created it and one person that reviewed it. That's the best audited body of code ever. It's really, really good. Publicly known body of code ever. Subsystem maintainers, they take them. So the subsystem would be like USB, networking, wireless. Now these developers have public trees. They have public trees on git.kernel.org, and they take the patches and they put them in there. We have about 100, maybe 130 different maintainers. I haven't guessed. Like I have a number of subsystem trees, so it's hard to do it by counting the number of trees. And those have public trees. And those public trees, every single day, they all get merged together into Linux Next. So this is our development stuff. Linux Next is done by Stephen Rothwell in Australia. He merges it all together, all the trees together. He says on a good day he can do it in 6 hours, and a bad day it takes him 12 hours. And he tells us what went wrong, because subsystems generally don't touch other subsystems. Like USB doesn't touch networking, but sometimes we do. And sometimes conflicts happen because I have to take patches that touch other things, and he lets us know. He lets us know what happens. He builds them all on all the different architectures that he can, which is, I think, 60 or 70, and then he boots a number of them. He does a number of them. And then at the same time, the subsystem trees are being pulled in by a bot we call the zero-day bot. It's run by Intel in China. It pulls every single public tree, and it tests every single patch that's ever gone in. And it will tell you, hey, you broke the build on this patch in the middle of the series. It's scary fast. I've pushed patches, went to get a coffee, and came back, and he said, okay, this bug is here, and this patch is wrong. The funny thing is, it's automatically sending fixes now, too. For common problems, for common warnings, he will automatically send a fix because he has scripts that does that. I don't know. We're trying to argue about the legality of patches created by scripts, who owns them, the copyright to them, but we take them. Yeah.
You do that on an post hoc basis rather than trying to make sure they're good when they go in.
I mean, before I put something in my tree, I think it's right. So I think it's okay. It looks good to me. The best thing about the zero-day bot is he builds for 80 different architectures. I build for my laptop.
But you do build for one architecture for every patch that goes in?
He does.
Do you?
Do I?
So what's the pre-submit stuff that goes in? Is it worked on my laptop good enough, or is there an official?
Worked on my laptop's good enough. And a lot of stuff I can't test. So if I take stuff for a driver that, I mean, I don't. But I do drivers. So the maintainers, like of the networking stack, he has a huge test suite that he runs on his stuff before he pushes to his public trees. Some architecture guys, I know the ARM, there's a huge ARM build farm we have of, I think, 80 different tiny ARM boards. And then they build on them all in different ones, and they'll come back and say, yes, they're good or not, before they put them in their public trees. They're in like semi-public trees, but not the tree that's not going to ever be rebased. So our public trees that go here are never rebased. They're good. If we get something wrong in it, we'll fix it, but usually it should always build. But a lot of times it's on random configurations, because we have a lot of different configurations that are odd, or different architectures. We keep breaking a few architectures that aren't maintained every once in a while.
So is it the case that each CPU vendor and each piece of hardware that's a driver, they are each individually motivated to build and test all their stuff? So you have this collection of motivated testers?
We used to think we had that.
Okay.
There used to be, we thought, hey, everybody's doing the testing. IBM is doing testing, Intel's doing testing, Google's doing testing. And all the companies said, hey, somebody else is doing it, we'll stop. So about 3 years ago, we realized nobody's testing. So Intel came along and said, we'll do the testing. And so besides our individual developers doing testing, so I'm testing on my stuff. ARM guys said, wait, we need to fix Lenaro, so let's build this big build bot, and we'll do a testing on a bunch of ARM stuff. And then Intel does, when we do cross builds for all these different architectures, we can boot them using QEMU, but we're not building and running on a Super H chip. Some architectures and some companies do care about it, and they will do that. But for generally, we just can't go fast enough. PowerPC, the Intel, our IBM guys do have a big farm. Stephen Rothwell works for IBM, so he does all the builds actually on a giant PowerPC machine that can do a whole kernel build in less than a minute. I think he's down to 10 or 15 seconds. That's the only way he can do all this stuff. So he pulls them all. We get that every day. Andrew Morton's kind of sitting off to the side. He's scooping up stuff that aren't maintained by other people. There are portions of the kernel that aren't maintained. People move away, people disappear, people pass away. So he scoops them up, and then he'll sometimes shove them off to the subsystem maintainers when he gets a chance. But he has a tree, and he'll send stuff to Linus too. So this is what we do every single day. This has nothing to do with Linus. So this is our development. This is our next kernel that we're doing. So when the release cycle happens and the Linus's tree is open, then we send everything to Linus. But we send it to Linus. He doesn't pull from the trees. And this is very important too, because sometimes our trees are messed up. So I maintained the TTY layer 1 kernel a number of years ago. The patches we had in there and what was going on there just was not stable. It was not working. It wasn't working very well. It would work for me, but not for a lot of other systems or a lot of other problems. So I said, no, I'm not going to push to Linus this time. I'll send him a few bug fixes. I'll hold off on my tree until it's good and stable for the next cycle. Again, 2.5 months, not a huge pressure. People who had bug fixes behind me, I could cherry pick around. And then I went, in the next release cycle, I sent it to Linus. We also do some numbers and statistics to figure out what ends up in Linus's tree if it was in Next or not. I think we're running about 95% of patches that go to Linus were in Next. Those other 5% are sometimes come in during the merge window. The networking subsystem moves so fast that a lot of stuff don't have time to test in Next. David has his own testing infrastructure. It's good enough. And sometimes they're just coming in from random places, so we have a bit of slop. Some subsystem maintainers forget to put their tree in Next. But it's really, we've gotten a lot better. It used to be about 70%, so we're doing better there. So hopefully everything's tested. So this is what we do. We throw it all to Linus, and then he does a release cycle. And then our subsystems, we spit off our trees again, make a tree for bug fixes only and a tree for our development, and we keep on going. So the important thing here is, if you're a developer, you don't care about Linus's merge window. You send it off to the maintainer. It's the maintainer's job to know when to send it off to what portion of what thing. So as a developer, if you have a bug fix, it'll get a fast track through. If it's a new feature, it'll take a slower track, wait for the next release cycle and whatnot. Don't make your developers have to care about your release cycle. That's the maintainer's job. It's easier that way. That way they don't have to worry about it. They don't have to go, oh no, I need to get the patch in now. Sometimes they do. They know that, since we're like at RC4 or RC5, we should get our patches in so it gets tested by Next. But generally, don't make the developers have to care about that. That way it makes things easier. Yeah. Questions? Concerns? Everything through email. Git from here on up. Everything else is through email. Yeah.
Is there like access control list that defines maintainers in a programmatic way, or just
Yes.
everyone knows?
So we have a maintainers file,
Okay.
and in there is listed. So it has my name for like USB, and it has everything in our driver's USB/star is owned by me. So if I have a patch, I have a tool that I can run against this patch and say, who do I send this to? And it says, oh, you need to send it to Greg. You need to copy this mailing list. You need to also copy these other people because they've had some patches contributed in this area recently. And that's how you know who to CC and who to send it to. You can also look at any file. I can say, give me this, who owns this file with that tool as well. Get maintainers, PL, Perl script, goes through the get history, looks at the maintainers file, sees who's touched it, whatnot. The side effect of that is sometimes you touch a file and then you're copied on patches for forever. So you don't want to touch the floppy driver, things like that.
Do you worry about making sure a patch you take was okayed by every driver file maintainer that touched, or do you just basically use trust in there?
So we do trust. Thank you. I was going to get to trust. So this whole thing looks like a pretty nice pyramid. Everything's beautiful and whatnot. Subsystems are cordoned off, so USB is independent from networking generally, but it's all about trust. So I trust the person below me. Linus trusts a few subsystem maintainers because he's doing git pulls. He's doing a pull. He doesn't look at the patches. He sends patches, whatnot. So subsystems are looking at patches, but I have some sub-maintainers that I just flat out trust, and I'll take whatever they have. I don't trust that they got it right. I trust that they'll be there to fix it if they got it wrong. And that's the important thing. You have to build trust that you're going to be around to fix it. Because if I take code from somebody, now that adds burden to my maintainership. Now I have to own this stuff. But if I know you're going to stick around and maintain it, I'm much more likely. So getting new code into the kernel, getting new developers in, it's a matter of, again, human interaction, trusting them and learning. So we recommend new developers start off with really simple patches, really simple things to fix, to know how to get through the process, to trust. Start reviewing other people's patches. If I see that you reviewed a patch, great. I think you know what you're doing now, and things like that. So again, it's all about trust. It's trust. It's a trust hierarchy. But we route around. So I actually graphed this a number of years ago, and it's a huge 1 meter by 10 meter long graph. That's just a giant, crazy networking thing, which is good because sometimes people die, people move away, people go on vacation. It's good. We can route around anybody. So maintainers have an ownership of a subsystem or ownership of a file, but it's not exclusive ownership. It's not like if networking guy wants to go in and touch the USB subsystem for something that he needs to do, I trust that he got it right. He'll fix it if he got it wrong. Have fun. So sometimes we do tree-wide changes. Tree-wide changes are hard. They get messy, and sometimes we'll go, okay, I'm just going to touch everything and make a separate tree and make sure it merges okay. Send it to Linus. I did copy all the maintainers, say, does this thing look wrong or right? That's it. And again, it's a matter of trust.
How does it get reintegrated then into your personal?
So then I pull from Linus's tree and update and go away from there. So I sync my development trees on like, if I push new changes to Linus, I'll sync on like RC1. And then if I sync later a couple RCs later, I'll do another sync. We don't want lots of merges in subsystem maintainers trees to Linus because that kind of looks funny. He'll yell at you, rightfully so. And that's the way it goes. So that's the way it goes. But again, trust. It's human interaction to trust. And because it's human interaction to trust, that's why a lot of us travel a lot. We meet people, we have a developer. All the subsystems have meetings at least once a year where all the developers get together. We have the plumbers conference, we have the kernel summit where the top maintainers get together and argue, is our process working or not? And do we need to tweak it or not? And things like that. And away we go from there. So, yeah. Any questions about how we do this? How do we promote? You're doing great. Want to do more work? I've given up. I think I've given up more subsystems than anybody else because I end up collecting them and I pass them on. And the way I do it is I'm like, hey, I don't want to do this anymore. Jean, you're doing a great job. Do you want to be maintainer? Only rule is if you want to give this up, talk to me about it first. Let's find somebody else to maintain it. So they'll go off and maintain it for a couple of years and go away from there. Maintainer. Some people don't want to be a maintainer. Maintainer involves reviewing changes and whatnot. There's a USB driver. I mean, I'm the maintainer of USB, but I don't do the work very much. I collect patches from other people. We have a very, very good USB developer who doesn't want to be the maintainer because he wants to do new work, he wants to fix bugs, he wants to do new stuff, and that would keep him from doing that work. So I'm willing, I'd gladly take any patches that Alan sends me, but he ostensibly is just a maintainer of this. He doesn't want to be a subsystem maintainer. It's a different skill set. and I'll show you some numbers in a little bit, subsystem maintainers very rarely do new work. All I do is review code. All I do is review code. I think I got maybe 100 changes in the kernel last year, which is kind of small. I'll show you the numbers in a bit. Yeah. So it's different. It's a different mentality, and it also means you as a developer have to give that up. David Miller said it the best. He's a networking maintainer. We're like an editor. We used to be a writer. Well, all we do every day is say, hey, you did great here. Why don't you change this there or do this there? And because we used to be a writer, we have a side, small, fun project on our own, and we still do development every once in a while. But basically, we're just editors now. It's a natural progression. It very rarely. Our biggest problem is getting rid of subsystem maintainers who aren't doing their job. That's our hardest part. It's much harder to get rid of somebody who's doing a flaky job. Some subsystem maintainers, like their day job is now working for a different company that has nothing to do with the subsystem they used to maintain. They're not allowed to have time to spend on it. How do we get rid of them? How do we do that? Or they're like incremental, like every 2 months this person shows up and does a little bit of work. How do we take those over? And that's where it gets hard. Promoting people up it's really, it happens automatically. It's kind of obvious. It's a very organic thing. That's the easy part. It's getting rid of people. It's hard. Yeah, it is pretty obvious. And some come in right away like, hey, I added a new subsystem. Boom, I'm now the maintainer of it. And some, like a lot of subsystems, like I maintain the character and MISC. So what that means is I take a lot of other tinier driver subsystems and they go through my trees to make those maintainers' lives easier. They can work on focusing on this tiny little driver subsystem and whatnot, and then they funnel their patches through me. I'll maintain the keeping things running properly. But yeah, it's very organic. It works out really well.
So maintainer, the word maintain is used a lot. So
yes.
Maintain implies something that has sort of been R&D'd already, and it's part of the kernel, and now it's evolving. Maybe it's really interesting work to evolve, but it's still maybe the core concepts existed already. Is there parts of the kernel where there's what I call greenfield development, like we're going to support this new feature that we never considered having in the kernel before, we're starting from no code? Does that happen, and what does that look like? Is it fit this model? Or?
Yeah, it fits that model. Usually people come to us with it. So we are, I mean, Lena says, I don't know what's going to happen in 5 years. I don't know what's going to happen next week. Because people submit stuff to us. I mean, we're busy with, I have all the things, I have my to-do list of what I want to do, new things. But it's people reacting to their environment and coming in with new features to us. Sometimes it's like, hey, this group of people came in, here's a feature, let's help them integrate it and do it properly and figure out how to do it. And that takes some work to do that, to tie it into the system. Sometimes new developers who are already doing stuff will go off and make new subsystems. That's kind of rare. Even rarer is where we have two competing groups doing the same project. And that's where things get messy. And that's where we have issues, because then it's a people management problem. And again, we have 4,000 people, but nobody works for anybody, right? I can't tell you what to do. And then we have, I mean, the original goal of what we have is, hey, both are doing the same thing. We're not going to take either until you guys agree. Usually that always solves it right there. Everybody's happy and they figure it out and work it out together. Very rarely will we have to choose A or B. And that has happened over the years every once in a while. And then, because then one group is mad and disappears, one group is happy. We really would have liked to merge it together. But greenfield stuff for brand new features sometimes comes from maintainers. But now these days, I mean, we're so busy just handling the flow coming in. Or we have our special side projects. Like I got a little side project that's a new subsystem that eventually will get merged in. And there's some greenfield stuff. But it's outside the kernel right now.
How much curation is there in that? So I really want to have a new kernel subsystem that handles coffee making.
Mm-hmm.
How do you say no or not say no?
I say yes to everything. Okay. So the easy things to say yes to is all hardware, new hardware types. Hardware type, if you're using, so we have the rule, if there's one user out there, we will support your code. We had a whole subsystem, our whole like a whole architecture, like a whole different CPU architecture, because there was 2 in the world. One of them finally got turned off, and then we argued to tell the other guy to turn his off so we could stop it and we could delete the code. And James finally did. I think his wife, when moving across the country, told him he wasn't turning that machine back on again. And then we were happy. But new hardware, easy, because new hardware is usually sub-thing. But even if it's tricky, we will take it because we want people to use it. New features are harder. And then we get to argue whether this feature is correct, and we have a whole bunch of criteria of how to add a new feature, what you have to go through, And like we're adding some new security features right now, and Linus said no because it was 1.5 nanoseconds, something crazy it added to a time with syscall. It wasn't microseconds. Anyway, yeah, microseconds. No, so there was like, hey, we're not going to hurt existing users. So we never want to break existing users, break existing workflows. That's our, okay. But no, we'll take anything. So, and that's actually worked out really well because people, but we make your work, so the famous example of this is power management. The embedded guys said power management is special and unique. We really care about it. It has to be done this way. Let's do it all over here. We said no, make it applicable for everybody. So power management went in for everybody, and turns out that if you save power, Google saves billions of dollars on infrastructure. So all the mainframe guys really liked all the power management stuff, but the embedded people did, right? We made it applicable for everybody, and that's very unique. We make it have to work for everybody. It takes more time. It's more effort, but it pays off better in the end because we have no deadlines. You have deadlines, which is hard to work against. My phrase is, you're special and unique just like everybody else. So, yeah, we make everything work that way. All right, I think I just have 2 more. So to give you a sense of what our developers do quantity-wise, here's the past quantity year last year. The interesting thing is not what these people do. I will call out Hartley. He used to do double that amount of work, but he just had his 2nd child, so now he's doing 1/2 the work. But Hartley works for a company that does embedded, or they do engraving systems. They make tombstones, engraving, big things. So he's going through a driver subsystem and cleaning up that driver subsystem. So he works for a tiny company. He's the only electrical engineer and programmer in the company, but he's going through and contributing huge amounts of code just to clean this up because Linux works really good for his company. There's something. But Geert and Arndt are doing really neat things. They're touching the whole tree. They're going through and cleaning up things all across the tree. So we have a number of people doing like janitorial work. Arndt got rid of all the build warnings on all architectures for like all the new compiler versions and just clean up build warnings. And he did a huge amount of work there. We want to make it really, really easy for you to, for us to accept janitorial patches. Don't make the burden of work be very high. We want to take drive-by patches very, very easily, and we want to make it really easy to take lots and lots of patches because keeping the code clean over time is very, very important. We want to make it very easy. So our top contributors are doing that. But then Alvaro rewrites the VFS layer. Mauro does video for Linux, huge new features, so he's adding things like that. So that's our size. So these are our top contributors' size. Our numbers are a lot flatter now. A decade ago, the top 25, 30 people did 80% of the work. Now the top, the top 200 did 60% of the work. So our numbers are much more flat. So of those 4,000 developers, we have half the people did 1 patch, half did 2, half did 3. It is an exponential curve, but our top is much more flat. It used to be really, really steep. So it's gotten a lot better. So this is what they do. So they do a lot of different things. So some are subsystem maintainers, but again, these are mostly just developers doing new work and doing drive-by stuff or code cleanups across the whole tree. And that's really good because you want it to be good. You want your code to be constantly kept up to date. New compiler versions, find new problems, keep it up to date. So this is reviews. So that's all I do. Again, I averaged, so I said 1/3 the patches I accept are, 1/3 the patches sent to me are I accept. So David Miller does networking and other stuff. Mark Brown does embedded sound. So here's, I show this thing because ostensibly Linus is at the top, but it comes down to trust. So Andrew Morton ends up sending all his patches through email to Linus. So Linus does review all the patches through email. Otherwise, Linus is taking pull requests from the rest of us, and he doesn't see those patches. So he's trusting that I got it right, or I'll be around to fix it up. He's trusting that Mauro got it all right, trusting that Acme got it right, things like that. So Ingo does x86. Daniel Vetter does Intel graphics, embedded sound, networking. It gives you a sense of how our rate of change is, how high it is. So the top people on that pyramid, those subsystem maintainers, are doing a lot of all we're doing is reviewing. With that kind of stuff, I don't have a lot of time to do new development. Yeah.
Over a year?
Yep.
Maybe like 50 a day or like 30, 40.
Yeah.
So some of that is like, I trust this guy, and like you don't even have to read much of it. Is that true?
Some of it, yes. So I also maintain like the staging subsystem, which is the crappy, horrible drivers, and it's the people getting involved in the kernel want to fix a coding style problem. So those I actually have to do review a lot of. But David does networking, so he's doing a lot of like really in-depth code review of this stuff. Yes, some of this stuff I do trust. Yeah, Alan, great. I'll take all your patches. But Alan's patches are maybe a month, right? Things like that. So
how many people do you have at this level?
I can do the numbers where it tapers off, you mean? Yeah. Maybe about a 50. Something like that. So most all these people, I think we only have 3 or 4 people are only allowed have their full job being working on the kernel. Everybody else has a day job that they have requirements to do for their employer. I think there's only 3 or 4 of us that are lucky enough to do this. But even with that, you get people that are able to do this kind of work, which is really, really good. Yeah, it's a large patch count. But the way we do it is through email, not through GitHub. And it makes it so that our tools are really, really fast. David uses Patchwork, which is also a nice tool. It takes patches from email lists and put them in web form, and then he can say, oh, look, this series, everybody's reviewed this series, okay, and go, and it dumps it to mailbox form, and he can pick and choose what he wants, put it through his tests and whatnot, and go off from there. Tools like Garrett slow people down. Tools like GitHub. GitHub has some security nasty issues with doing pull requests, so we just don't do that. We will do pull requests for our subsystems to Linus, but that's, again, through email and then git.kernel.org, which we trust. So, yeah. But maintainers, we have to find people that are willing to stop doing new development, that are willing to do review of the project. And that's hard for projects too. It's hard for people to be willing to give that up. It's a different skill set, and it's hard. I've worked with a number of other projects that their developers don't want to do that, and that's fine, but you need to find people that do have that skill.
Is it basically because of that context streaming, rather than getting twice the number of maintainers, do it half time?
Context, sometimes it's good to start with, but usually like people gravitate to, so like, I don't mind, I like helping other people. So it's a mentality of what you like doing and what you don't like doing. Some developers don't like reviewing other people or telling no. I mean, our job is to say no a lot, and that wears on you. I mean, it's wearing when different people send the same bad stuff all the time. It gets to you because they're not reading other people's stuff, and there's new people coming in all the time. It can be wearing, and it can be tough like that. And you're feeling like, hey, I used to be a developer. So we do show, we like to show this and show our maintainers because it's a very important part of what we do. So we like to show them off that way and give them recognition. Code review, we also show who has done reviews as well when we publish these numbers every release or every couple of years. Who's been doing reviews, because we want other people to review other people's stuff. That's very, very important. Reviewing other people's stuff is also very important because we want people to learn and people to grow. So patches on Garrett or patches on GitHub are hard for non-maintainers to see. So it's all on the public mailing list, it's all on the USB mailing list, all the USB developers see it, and they can chime in, they can do drive-by reviews very easily. GitHub and Garrett, those type of tools make it very hard for somebody doing drive-by to even notice the patches are there. And that's because you want new developers to come along, learn from other people, because it's easier, you want to learn to read before you write, right? You don't want to be writing.
Can you describe the evolution of the subsystems? I know that there's been a few controversial ones, like the merger of x86 and x86-64, but it seems like it's pretty dynamic.
Yeah, sometimes it's like when things get, oh, look, the two x86 trees the code is duplicated everywhere here. Wow, what do we do? Let's take the time, merge them together, respin everything, and do it right. We just rewrote our floating point, old floating point emulation code in x86 because it was messy and copied a bunch of different places. Somebody saw it and said, let's fix that up. Yeah, it's, again, code quality and stinkiness and whatnot. We have no problem with redoing old stuff. Again, we just rewrote the locks.
But to bring in a new subsystem.
Bringing a new subsystem, I mean, yeah, x86 was like, they realized that one person couldn't be the maintainer, and they needed to share it. So we have a number of teams now. So x86 is shared among 3 people. ARM is shared about 3 or 4 people share that duty. They do a rotation every week, and they have some other way they talk to each other, and they pass it off because their employer wasn't allowing somebody to do it all the time. Shared is good, so you don't get burned out. SCSI just went to a shared model because SCSI wasn't working out so well, just one developer. Things like that. Some can go to share. So you can share it. That's actually really, really good. Somebody goes on vacation, things like that. I share it with one of my subsystems, but Arndt is on paternity leaves for 6 months, so which is fine, which is good. I'll pick it up for them while he's gone. So it's shared, but he's not doing work at the moment.
Who
else is following this model besides the Linux kernel? And in particular, is there any track record of a company moving from a project moving from GitHub pull requests over to this model? Or vice versa?
Mozilla does a lot. I don't know how WebKit works. I really don't. I really want to figure that out. I haven't talked to those guys. All right, thanks. I'm not sure how WebKit works. Mozilla does something a little bit like this. Docker has split their tree up into different subsystems, and now they maintain them individually on GitHub so that they can do that in different ways, and that works out well. You guys are going to have to split your tree. You guys are going crazy.
I don't think there's any question about splitting the tree. I think the question is particularly, I know we didn't get to this yet, but like general issues, right? There, like for every one developer, there's 10 or 50 people who are like, I want this, right? You know, whatever. Do you just do that via like Linux users, or like where do you get the seed such that and how you prioritize, you know?
Well, again, we take what people have sent us, right?
But my point is, I guess a developer doesn't even know to work on something yet until they hear from some people who.
Okay, so we don't have that problem. We have code that shows up because people know they want their hardware to work, right? So we don't have the problem of developers not knowing what to work on. Like I said, all the top developers, we all have a list of things that we've seen over the years. We're starting to publish that. We have a list of easy things to do. Our problem with the kernel is you go from I do a lot of easy little tasks, now I know now what do I work on? And finding intermediate tasks is hard. And I was supposed to help this out, and I've been busy with other things, but some subsystem maintainers are saying, here's some moderate tasks to work on. I don't have the time to do it, and they publish them. Here's something you should. And so that gets developers in and whatnot. That's but learning from users, like you're having to respond to users and what they need to do, and that's harder. We do respond to bug requests all the time and things like that, or look, this broke, how we need to fix this, but new features are a little harder.
You talked a little bit about new users, new developers, and onboarding. How do you offer feedback beyond or growth paths beyond straight up? Here's the review. It worked. It didn't work. How much time do you spend on that on early new developers?
Early new developers, the best thing we can do is take their patch. We take it, we say, and then you get that little dopamine hit of, hey, look, my name's in the kernel. And then you get the 3 recruiters asking you for a job to work for them. Because, I mean, the joke is 5 patches in the kernel, you get a job. It's not really a joke. So we have that feedback loop. So but it's an internal feedback loop of, look, my change got into something that everybody in the world uses. But that's about it as far as, and but we want to, as a maintainer, I want to be able to review a patch within a week or 2, depending on how I'm traveling, to give them feedback. I don't want them to feel like they sent something off into the ether and never got a response. Right. And that's my job as a maintainer to do that. And so we try and put strict, we try and encourage, we don't make it mandatory because people objected, but really, maintainers should be responsive. And that's our
week to 2 weeks is your current.
Yeah, depending on our merge window time or travel and vacation, stuff like that. But I try and do it within a week, 2 weeks. I've been ignoring some serial patches lately. I need to catch up. But yeah, generally that.
You mentioned that Mozilla is doing something like this. Do you have portable tooling, or is it highly bespoke to your system?
We have portable tooling. So Patchwork is the only tooling that we might have, and that's you can pick patches off a mailing list. Other projects use that. That's public. It's a public project. And we use Git, which we created. Everybody uses now. And I have a set of tiny scripts that I have, which are public, but those all maintainers end up writing a few little scripts. We have other tools called Quilt, which is maintaining patches against the base that people use now, distros use. So all our tools are public and other people use. Nothing's really bespoke. Git was bespoke in the beginning, and that's grown. We have our own version of host. We host our own version, but that's because we want control. But no, yeah. And that's it.
Okay.
Thanks. Thanks.
All 3 of us.
All of Mountain View was there on the left there.
Oh, they all disappeared.
The entire time. I don't know if they have any questions or anything.
I think they're gone.
Yeah,
And the one way on the left, the big 50-person
the
room
big
there on
empty
the left.
one, yeah.
Yeah.
Right? They were gone. Yeah. Seeing people right over there. Okay.